plus the h size, and then my function is the t plus the y. The t comes from here, the y comes from here. All right? So that would be an Euler's step, and that's the first step you have to do in the improved Euler's method. Now, what am I going to put in this one? Well, once again, the y comes from up here. All right? So, sorry, this square here. This square, the y comes from the one above it. Then I take the step size over 2, that's just in the improved Euler's formula. Here, I do that Euler step comes from the Tn Yn, right? The one from the row above it. Then I do the updated time. Well, that updated time comes from here, the time below it. This is where some people get confused. That's the time below it. And what was this? This was the Euler's one. That's the computation I made right there. Okay. And so now, there I have the improved Euler's formula right here in this one, calling on these 3 cells and this cell over here. Now, of course, you could just change this E5 to be E4 plus H. That would look fine also. That's just what you, all right, and so then we can then go down and do the iterations. All right, so the improved Euler, and by the way, calculations, the y values are going to be in this column. Okay? This column are the ones of interest. Here's the time, here's the y. And let's just look at, I think if I go up one, okay. Let's look across here. Again, we solved this differential equation. Here was the exact solution, 8.87313. Okay, that's what it is exactly. The Euler's approximation came out to be 8.3749. See, we're already off by 0.5. Okay? That's a pretty big error right there. But look at the improved Euler's. We're only off by 0.02. All right? Now let's remember what happened here. To go from 0 to 1, how many function evaluations did I have to do?
10.
10 of them. I had to do 10 function evaluations. 10 function evaluations left me with a 0.5 error. How many function evaluations did I have to get here? It's the improved Euler's. I had to do 20 of them, right? I had to do the function evaluation to get my Euler's value, and I had to do the function evaluation to do my, using that Euler's method and the time to get a new one. So I had to do 20 evaluations to get here, but I went from a 0.5 error to 0.02 error. Much better, right? A huge improvement. And that gets to be with the fact that this is being order h squared. Okay. All right. Is everybody okay with this spreadsheet? What would you do with a new problem? Well, of course, you'd put a new function in here, right? Yes.
Can you show us just how to graph it really fast, please? Okay. Just you don't have to show it, but so we copy and paste the columns, and I'm curious. I want to do it in MATLAB. So I know like copy and paste the.
I will just do it in Excel here.
But to do it in MATLAB, what's the?
You have to use the plot routine.
You have to do what?
You have to do the plot routine with the.
But how do you connect the dots?
How do you connect the dots?
Yeah, like how do you? I know you can plot like dots.
Okay. I can tell you that.
Yeah, that's all I'm curious about.
So this one, you could do this, and you could do insert this plot right here, and you could do connect dots. Who knows what this is? Anyhow, you can. This is what you can do MATLAB, so let me just kill this graph. Confuse people. For MATLAB, the command you're looking at is plot t comma y comma quote. Let me do a blue line with dots. You would do B O minus dot. So that does open circles with connecting line.
Okay, and that does a curve? It's gonna make
No,
it.
it's connect the dots. Does a straight line between your dots.
Oh, you're right. Yeah, my bad. Okay, cool.
That's an O or a 0?
That's an O. That's a little O. Okay, we'll do those circles, and we'll, and one of the ways you can do, of course, you could also look this up, right? You go to my webpage, and you go up to, let's do numerical example 2 plot. Then, look on this particular one.
Okay.
By the way, the order doesn't matter, whether it's O minus or minus O.
Okay.
This says a red circle line, this is a black circle line, this is just a blue line. Okay. So I have this stuff in here.
Okay.
And by the way, this one has solve with the numerical ODE 2-3. Right? This even shows you how to do the numerical ODE 2-3 solver in here.
Cool. Thank you.
So this one calls the ODE 2-3 solver, the Euler's method, the improved Euler's method, and then it wraps them.
All in that. As long as you have the functions.
As long as you've got so it's calling this function, numerical example 2,
Okay.
which we'll get to. So yeah, this one, as I like to say, I'm providing you with the MATLAB ones. Yeah, if you want to understand it, you got to read these lines. I'm trying to tell you they're not that hard to read. Dash, circle, circle, dash. It should be pretty obvious. Do take advantage of these programs I've provided you with. Again, how do you best learn programs? You copy from somebody else and modify them to start with. That's the first claim of learning a program until you're familiar with it. And then when you don't understand something, then you either Google it or ask somebody else. What's the biggest problem? Well, people forget a comma here or something like that. That's where you have somebody looking over your shoulder. Okay, so hopefully all these commands are easy for you to see. All right, so let's get back to what we were doing for numerical ones. All right, so there's the